Hello fellow chemists, in this video we're going to take a look at how to balance chemical equations. This is listed as an intermediate level video because it assumes that you have a basic understanding of types of chemical reactions. If you need a review of that topic, I will put a link in the upper right hand corner. So I have the rules here for balancing a chemical equation, but in general, if you have a chemical equation like the one we have drawn out here, you have an arrow which is dividing your reactants from your products. And you have to have the same number of each type of atom on the reactant side as you do on your product side. And the only thing that you can change is the coefficients in front of each of the terms. So right now, if there's nothing written there, we assume that it's a 1 in front of each of these terms. So that number you can change. You can change it from a 1 to a 2 to a 3 or whatever. What you cannot change are these subscripts. That would be literally like changing lead into gold. You'd be turning one substance into another substance. So we cannot change those subscripts. We can only change these coefficients out in front of each of the terms. So let's just kind of read through the process that we're going to go through, and then we'll do an example of it up here for the equation I have written out. So first it just says examine the equation and pick one element to balance first. So look, we either have iron, we have iodide, or we have chlorine. So just pick whatever one you want. I usually just pick the first one that's in the equation. Then you just check and see how many irons are on one side and how many irons on the other side. If they're not equal, you change the coefficients in front. Then you pick a second element and do the same thing for the second element. And then any time that you change a coefficient, you basically have to revert back and start over at step 1 and redo all of the elements over again. And then when you're finally done and you go through all of the elements, you got through all the elements and didn't need to change anything, then you just go through and recount up all the elements on each side of the equation to make sure that they are the same. So let's kind of go through this. We'll go through each of the steps for this equation and make sure that it's properly balanced. So we're going to start off with iron. Now what I like to do is I just draw the molecules out underneath of it. And it doesn't matter if they're drawn correctly with the right number of bonds or anything. But you have FeI2. So you have an iron that has 2 iodides attached to it. Don't worry if it's one bond each, or don't worry about non-bonding electrons or anything. This is just to physically show the I2 as 2 iodides, so you can just physically count them up. So I have an iron here, I have a Cl2 here, so I'm just going to go Cl, line Cl, it's Cl2. Then I have an FeCl3, that means it's one iron with 3 chlorines attached. So I'll do an iron. I don't care if it's single bonds, double bonds, triple bonds. Don't worry about that. Just show that the chlorines are attached. So you got one iron and 3 chlorines. That's what this molecule represents here. And then you have an I2. So that's 2 iodides. So now we can kind of see on the left-hand side we have one iron, and on the right-hand side we have one iron. So good. Iron's all taken care of. Now we're going to take a look at the second element, iodide. I have 1, 2 iodides on the left, and I have 1, 2 iodides on the right. Great, that element's taken care of. I don't need to change any of the coefficients. Then we take a look at the third one, chlorine. I have 1, 2 chlorines on the left, but I have 1, 2, 3 chlorines on the right. They're not the same. I need more chlorines on the left. So what I'm going to do is I'm going to change this 1 to a 2. Now that means I have 2 of these Cl2 molecules. Well, let's draw that out. I have another Cl2 molecule. So now I have a total of 1, 2, 3, 4 chlorines on the left, but only 1, 2, 3 chlorines on the right. Well, now I need more chlorines on the right, so now I need to change this one to a 2. All right, so now I draw on my second molecule of this. Now I have 1, 2, 3, 4, 5, 6 chlorines on the right, but I only have 1, 2, 3, 4 chlorines on the left. All right, well, since this one's too low now I change this to a 3. So I have to draw my third chlorine molecule in. Now I have 1, 2, 3, 4, 5, 6 chlorines on the left, and I have 1, 2, 3, 4, 5, 6 chlorines on the right. Now, once you get fairly good at this, you don't need to draw the molecules out underneath. But if you're new to this, that really helps so that you can see each of the individual atoms. So now we have 6 chlorines on the left and 6 chlorines on the right. So they're balanced, so that's good. But remember, if you change any of the coefficients, you have to go back and start over with the other elements. So now we got to look at iron again. All right, now I have 1 iron on the left, but I have 2 irons on the right. So this needs to increase, so I'm going to add another molecule of FeI2 in. So change that to a 2. Then I'll draw a second molecule of FeI2. And again, don't worry about the bond angles or if it's single or double bonds. We're just trying to show the physical atoms here. So now you got 2 irons on the left and 2 irons on the right. So that's balanced. Okay, so I'm going to put 2 irons, 2 irons. So they're balanced. All right, now we'll take a look at the iodide. All right, so the iodide, I have 1, 2, 3, 4 iodides on the left, but I only have 1, 2 iodides on the right. All right, well, I need more of them on the right, so I'm going to change this 1 to a 2. And I'll draw in the second molecule of iodide over here. So now I have 1, 2, 3, 4 iodides on the right, and I have 1, 2, 3, 4 iodides on the left, so the iodides are balanced. So I got 4 iodides on each side. But now since I switched the iodides, I got to go back and recheck the irons, make sure I didn't mess them up. I have 1, 2 irons on the left and 1, 2 irons on the right, so they're good. The iodides, we just did them. 1, 2, 3, 4 iodides on the left, 1, 2, 3, 4 iodides on the right. Now we need to check the chlorine one more time. I have 1, 2, 3, 4, 5, 6 chlorines on the left and 1, 2, 3, 4, 5, 6 chlorines on the right. So we can see everything matches up. You got 2 irons on the left, 2 irons on the right, 4 iodides on the left, 4 iodides on the right, 6 chlorines on the left, and 6 chlorines on the right. And this last step basically just means once you finally go through everything and you don't need to change any of the numbers, you just do this last check, where you just check 2 irons, 2 irons, 4 iodides, 4 iodides, 6 chlorines, and 6 chlorines. So the correct balanced equation would be 2 FeI2 plus 3 Cl2 yields 2 FeCl3 plus 2I2. And again, this is taking the extra steps of drawing out the molecules down here. Once you get better at this, you may not need to do that, but I do strongly encourage and tell my students, if you're very new to this and you have trouble understanding what these subscripts mean and you're kind of losing track of atoms, just draw a little picture of the molecule out beneath it, but it makes it a lot easier just to keep track of each of the individual atoms. All right, that's the basic steps for how to balance a chemical equation. I hope you learned something. In the next video, we'll look at more advanced equations to balance, and I'll see you in the next lesson.